Hello, everyone. I recently received a comment on one of my Soroban videos. It was like a Japanese abacus that I was reviewing, and somebody had mentioned Trachtenberg, which piqued my curiosity. So I started reading up on the method and trying to understand what's going on with it, and it took me a little while to figure it out. I still don't exactly know what is going on with it, but I've made some insights into what I think is happening, which I wanted to share with you. And it involves trains. Curiously enough, called the Braun train visualization, is a way to understand Trachtenberg multiplications, perhaps in generally speaking, in a way that makes more sense. So I'm going to start off going over the traditional methods of multiplication that I learned in school, and then we'll go into what Trachtenberg is, I believe, trying to do with the multiplication method that helps to do things easier and perhaps mentally. And then we'll look into how trains can help visualize what is going on. So let's start off first with different multiplication scenarios. So this is just in general. Obviously, 1 by 1 digit multiplications are just a simple multiplication table which you should be memorizing. For example, you'll see here on the slide, 1 digit by 1 digit would be, for example, 2 times 3, which is 6. Okay. Now you can do a 2 times 1 digit. I didn't include this entry because 1 times 2 is the same as 2 times 1 digit. So you'll notice that this section here is basically blocked out because it's really just a duplicate of the other top rows there. Okay, so a 2-digit number, for example, is 34 times a 1-digit number, 2. Okay, and then if you have 2 digits times 2 digits, it's, for example, 23 times 45. And then with 3 digits, you can have 1 number times 3, the 2-number digit times 3, and so on. And then for 4 digits, same pattern. And the last number example here is 4-digit number times 4-digit number. Okay? Now, how do I understand multiplication? To me, multiplications are like areas. Okay? So for example, the number 23 is actually just 20 plus 3. Okay? So imagine you have a side. This side here of the box is 20 centimeters, and this is 3. Okay, so that's the area. The number 45 is really just a 40 plus a 5, which gives us 45. So you have again a box where this side here is 40 and this side here is 5. And then you end up with this table. So one box of the table of this this area is really sided 40 by 20. So that's what that is. This top rectangle is the remaining bit, which is 3 times 40. And then you have this other section here, which is 20 by 5. And then you have that last little corner, which is the last bits of the box, which is 3 times 5. So you really have 4 boxes when you multiply 23 by 45. And sometimes it helps to visualize that because you can add it up, right? So if we did the math here, these are just showing that there's 1 0, in here and here. And there's 2 zeros in this box. And there's no zeros in this box, which will become apparent later on when we look at some different things that are interesting. And that's only because, remember, there's a 0 here and a 0 here, and there's no 0 here and no 0 here. So when the multiplication happens, you get 2 zeros in here, 1 0 in here because it comes from the 40. You get 1 0 in here because it comes from the 20, and you get no zeros in this top corner box. Okay, but the reason I say that is because you can group the zeros. So to make it easier, you can multiply, 8, 12, 15, and 10 in your head very quickly. So that's what we've done there. And then you just tag on the zeros. In this case, when you do that and you put the numbers in their respective places here, right? 120, there's the 100, and this is 800. You add it all up and you get the answer fairly quickly. So it can sometimes help in your head to do these multiplications just by, you're multiplying these, and then, you can sort of add it up in your head. You get the idea, okay? Now, the traditional method I was taught was to do it in steps. So you start off with the 5 digits, and you multiply by 3, and you move on to the 2, and you put it in the first row, right? And then you do the 4, you multiply by 3, and then by 2, and you put it in a second row, but you indent it because you put a 0 here. And then you add it all up, and you get the answer, okay? So let's go through that. So 5 times 3 is 15. Carry the 1 above. 5 times 2 is 10, plus 1, and you'll get 11 over here, okay? And that's the first line, which is basically 5 times 23. We go to the next row. You have to indent because now you're actually multiplying by 40, not by 4. You just don't realize that. But you put 4 times 3. You put a 2 here. 1 goes on top. 4 times 2 is 8, plus 1 is 9. Okay, so we'll see that. There you go. 4 times 3 is 12. Carry the 1. 4 times 2 is 8, plus 1. You get 9. And then you add it all up. And you get the answer, same as before. How did we get that geometrically? Well, have a look. 20 times 4 is really 8. 2 times 4 with 2 zeros. 3 times 40 is 12 with 1 0. Put that here. So let's go back. And, the 5 by 20 is 5 times 2, which is 10, with 1 0. And 5 times 3 is 15. Okay, so let's go through each step. The traditional method, you start off the first column here, 5 by 3. That's what we're calculating first. Okay, that's the first thing we're calculating. Then you go here, 5 times 2, you get 10. Plus the 1 that was carried over from the 15, and you end up with 11. But what you're doing is, you're not doing that yet. What you're doing is 5 times 2 only, and that's 100. And then when you add them together, right, 15 and 100 here, it comes up to this column here. Okay, so you'll see that when we add them up later. When we do the next column for 45, the 4 times 3, we get 12. And then 4 times 2 is 8, 0, 0. And then when we add them up, we get 115 here. And here we get 920. Right? And then you add that up to get your answer, which is 1035. Okay? So the order is this, then this, then this, and then you finally figure out this one, and then you add them up. All right? Let's have a look at a 3-digit problem. Same exact thing. You do 4 times 7 over here, 28. You move along the top row, 7 times 3, 21. You put the 21 there. Add a 0 because this is no longer in the first digits column. It's in the tens column. So it's actually a 30, right? The next one is actually in the third column, so it's actually 200 that we're doing. So that's 200. So 7 times 2, 14, plus 2 zeros after it. You do exactly the same thing with the next column. By the way, when you add all this up, you get 1638, which is what you would get in the traditional method in the first column there, in the first row, I should say. Okay, now let's start with the second. 6 times 4 is 24. Now there's an extra 0 here because, remember, let's go back for a second. This is actually, we're pretending that's 60 because we've dealt with the 7 already. Okay. Next column over, 6 times 3 is 18. It's got 2 zeros because this is actually 60 and 30. Okay. And then 6 times 2 is 12. And we have 3 zeros because we're actually doing 60 times 200. Okay. And so on for the same. So when we add all this up, we get 14040, which is what we normally get in the second row here when we do the traditional method. And for the final row, I'm just going to quickly go through this. Right? 5 times 4 is 20 with 2 zeros after it. 5 times 3 is 15 with 3 zeros after it. And 5 times 2 is 10 with 4 zeros after it. Add them all up, we get 117,000, becomes the third row, and then the total is this when you add it all up, okay? But one of the interesting things is we can write this all out as powers of 10 because these numbers, as I mentioned, when we're multiplying in the table, these are powers of 10. 234, which is our first number we added here, is 200, which is 2 times 10 to the 2, plus 3 times 10 to the 1, plus 4 times 10 to the 0. The same goes for 576. It's actually 500, which is 5 times 10 squared, right? 5 times 10 squared. Sorry about my mouse there, right? 60 is 6 times 10. We'll just say it's to the power 1. And 7 is 7 times 10 to the 0, because any number to the power 0 is 1. Okay? So let's go through this. We now have the same exact multiplication, 234 times 567, written as powers of 10. So this is 234 right there. 234. And this here at the bottom is 567. 567. When we do each column, we multiply 7 times 4, for example, we get 28. 7 times 3 is 21. 7 times 2 is 14. But the powers have to be kept in mind. So if you do it times 10 to the 0 times a 10 to the 2, you add the exponents. So this becomes 10 to the 2. And so on throughout the table. So you'll notice that in this bottom column here, bottom section, because we've done 5 times 2, but the 10 is to the power 2, and this 10 is to the power 2, we put 10 to the power 4 there. And you'll notice there's a pattern. 0 is up here. All of the 1s are here in diagonal. All the 2s are diagonally here. All the 3s are diagonally here, and all the 4s are here. And that's going to be important later. If we write it in color, you see 28 to 10 to the power of 0. These, being exactly the same power, can be added because they're in the same magnitude, which it becomes 45, right? These, which are also in the same order of magnitude of 10 to the power of 2, can also be added. You get 52, right? Because 18 plus 14 is what, 32 plus 20. These can be added because they're also in the same power of 2. Same power of 10. That's 27. And this doesn't have to be added because it's on its own. So let's do that. Diagonals are the same power, okay? So watch. That's 28 times 10 to the 0. which is really just 28 times 1. This is 45 times 10 to the 1. When you add that diagonal, it's 52 times 10 squared. And then the last two are 27 and 10 with their respective multiplications of powers of 10. When you add up those results, I've just basically expanded them by adding the appropriate number of zeros, okay? 1 0, 2 0, 3 0, and 4 zeros. You line them all up in a column, and you add them, and you get the answer very easily, okay? So essentially, the traditional method of multiplication, when you do it in rows and you indent it, you're really figuring out the answer like this. You're going down this part of that geometric grid I showed before, then you're going this way, and then you're going this way. So you're adding up each line and totaling, several different powers of 10. That's why you have quite a complex system of numbers underneath. With the Trachtenberg method, my understanding is, in general, you're combining powers of 10. And that's why it's easier to add up afterwards, because you're going diagonally through the table. You're going through the same power of 10 numbers. And the reason that's true is because for whatever power of 10 is here, plus here, equals, this one plus this one, right? That equals this one plus this one. Essentially, as you go down this way and you go this way, you keep the same power of 10, because if this is a power of 10 of let's say 2 1 0, or it should be the other way around, 0 1 2, and this is 0 1 2, right? If you add 0 plus 2, you get the same. It should be actually the other direction, but you get the idea. Powers of 10 and diagonals are the same if you write it out, the numbers in a specific way. So the power of 10 to the power of 10 to the 2, power of 10 to the 1, power of 10 to the 0 number digit. And if you do the same here, 0 plus 1, you can get 0 plus 1 there, and you can get 0 plus 1 there. So that means this cell and this cell have the same power of 10, right? Okay, let's see traditionally how we multiply. 4 by 7, we get 28. The bracket here in orange is showing you the numbers that are being multiplied, 4 and 7. Okay, then 3 times 7, and shift it over by a 0. And then 2 by 7, shifted over by 2 zeros, and then you add that up, 1638. Okay? Then you go to the next number, 6, and you do the same. You do by 4, by 3, by 2, you get 240, 1800, and 12,000. Add that all up, and you get the next row. And then finally, you do 5 times 4 to get 20, but you add 2 zeros because we're now shifted over by 2 spaces with the 5. Then 15 with 3 zeros, and then 10 with 4 zeros. You add it all up, 117,000, and there's your total, 132,678. Okay? Now let's try the Trachtenberg method. We're doing diagonals here, so you have to keep in mind which you're multiplying, right? If you remember, when we did the Trachtenberg table, we started off with the smallest digits first. The top, here, I'll show you let's just pretend here's our grid, like that. Okay, 2, 3, 4, and 5, 6, 7. So we do this one first, which would be 4 times 7. But we don't multiply the 5 and the 6 yet. Okay? So the arches go like this. And then 5 and 6 multiply against blank spaces, so they're not included. So if you do that, you get 4 times 7, 0 and 0, and you get 28 for all your 10 powers, 10 to the power 0 numbers, okay? Then you shift the tracks along. So again, if you remember the table, the next thing we did, we want to get all our powers of 10 to the 1, which happen to be in this and in here, right? So once again, we have 2, 3, 4, and then we have 567 here. So we do 4 times 6 and 3 times 7. So there's 4 times 6, 3 times 7. And then the method also makes it 5 times the blank. So we've added up, now multiplied and added up these two powers, which come out to power 10 to the 1 powers, and that's 45. Okay? Similarly, 10 to the 2 powers are in, if we look at our table again, I'm not going to rewrite the number, but you get the idea. We now want to add up this one, and this one. So we multiply whatever that is, and whatever that is, which happens to be 2 times 7, 3 times 6, and 4 times 5, right? This would be 2 times 7, 3 times 6, and this was 4 times 5, okay? We add them all up, and we get 52. That's our 10 to the 2 power number. Okay, so we write it down here. And continuing on the table, now we're same thing again. We'll draw our grid, right? We have to do now this one and this one. This happens to be a 3 times 5. So that's our 15. And this is a 4 times, a 2 times 6. 2 times 6? Yeah. Which then gives us our 10 to the 3 power. So when you add this up, you get 27. And then 10 to the 4 powers would just be the 2 times the 5. So we're now figuring out our last cell in the grid, right? Remember again, we have 2, 3, 4, 5, 6, 7, and we're now figuring out this last square here, which is 2 times 5, which is right there. Okay? And then we write that down at the bottom. Okay? So you're doing it in opposing order, right? You're doing always, as you move this way on one number, you move the other way on the other number, because that way the powers of 10 that you're resulting in your multiplication end up at the same level, right? If you start your arches here, your powers of 10 are always going to add up when you multiply all these, like 4 times 7, blank times 6, which would be 0, blank times 5, which would be 0, and you add them all up, you're still in the 10 to the power 0 group, right? If you jump the other way, let's say you go to here, and you do that, right? Because your 3 is in the 10 to the power 1 group, and this is in the 10 to the power 0, your answer, 7 times 3, would be times 10 to the 1, okay? The 4 is a 10 to the 0 number, but the 6 is a 10 to the 1 number. So the result is also 10 to the 1, and so on. That's why you go this way and this way. Basically, as your 10 power decreases in one number, it increases in the other, and then the result is in the same group. That's why your arc keeps moving, right? And it doesn't cross over. So your arc just keeps moving over, right? When you do 234 by 5, 6, 7, now this is in the 10 to the 2 group, and this is in the 10 to the 0 group. So the result is a 10 to the 2. This is a 10 to the 1, and this is a 10 to the 1. So 1 and 1 is 2, and this is a 10 to the 0, and this is a 10 to the 2 group. So that also adds up to 10 to the 2. So when you multiply all these out and add them, they're going to end up in your 10 to the 2 group. Okay? At some point, you're going to have to move your arch out of the actual space, and then you end up with numbers that are bigger, right? If you're out here, and so on, right? Like, let's say you move the arches out further, even, like here. So now you're skipping the 4 altogether, and your 7 is multiplying against the space, so it's skipped as well. So, and that's how it essentially progresses. So if we end up adding up what we just did in the last calculation, we end up with the same answer again. Okay? So let's try another example. This is 23 times 45. I created some blanks here just to show you how it's done. This is the 10 to the 0 group, multiplying 3 times 5 plus blank times 4, which is really just 3 times 5, 15. Then you move the arches out more. You end up with the outer numbers, 2 times 5 plus 3 times 4, which is 10 plus 12. You get 22 times 10 to the 1. And then the final group, you move the arches over again, and now you're into the 10 to the 2 group, which is 8, 2 times 4, and 3 times blank. So that doesn't count anymore. Okay? Same, the answer is 1035. You can do the same with 2 digits and 3-digit numbers. It doesn't really matter. You just move your arches until you end up having all of the numbers calculate each other out and all the groups. Let's go through this example quickly. So we start off with the smallest, the 10 to the 0 group, which is here. This should really say 0. It's a mistake. Let me see if I corrected myself later. I didn't. But anyway, yeah, it should say 0 here, because we've done 3 times 6, which is 18. Okay? And this is correct. Or is it? Oh, yeah, it is, because we've shifted over. So this is the second group. So we're now 2 times 6, which is 12. 3 times 5, which is 15. So that's 27. And the 4, the blank times the 4, which is nothing. And because this is the next group out, we get 10 to the 1. Okay, we do the exact same thing again, moving out further. We're in the 10 to the 2 group, we get 22, right? That's 2 times 5 is 10 plus 12. And then here, 2 times 4 is 8. And then the rest calculate out to 0 because they're already connecting with, the arch is connecting to blanks. So we get just the 2 times 4, which is the 8. And we're in the 10 to the 3 group. At that point, we're finished because the rest of the groups, as we go further out, line up with zeros, right? You see this outer arch, 5 times nothing, 4 times nothing, and here we have nothing times 2. And then the same with this one. If we move out further, we have 4 times nothing, a blank, and a blank times whatever. So it's still 0. So if we add up 18, 270, 2200, 8,000, we get the answer right here. That's the correct answer. So it works with 2 or 3 digits or combinations. It doesn't really matter. So as a general rule, always start with the 1 column. That's the 10 to the 0 power. And then expand and shift one side of your arches over. Now there's an infinite number of arches, right? I only drew 4 here, but you can do this, and you can do this, and you can do this. It's just that more and more of the arches line up with blanks, so they basically do nothing. They give you 0, okay? And the same goes the other way. You can keep going like this, and more arches add up to nothing because they're including the zeros here, the nothing spaces. So what you're doing is sliding one end of your arch points here across your number. And every time you do that, they're lined up differently. The two numbers are lined up differently, so that you end up with a higher 10 power, right? As you shift over the arch, or this number, where arch lands on, from this number to this number, your power goes up. Okay, so you can practice a few things. Let's practice for now 67 times 52. And in your head, you might be able to do it quicker if you practice. Let's go forward here. So if you want to pause the video for a moment here, you can try that on a piece of paper and see what you get. And I'll be back in a moment, and we'll figure out what this means. Okay, so here we are. You with me? So we started with 7 times 2. That's our first arch. Of course, the blank times 5 doesn't come out to anything. That gives us 14. Next row, powers of 10 to the 1. We shift the arch. 6 times 2 plus 7 times 5. So that's 12 plus 35, which is 47. Of course, with a 0, because it's a 10 to the power 1. And then finally, we shift the arches again, and we get that 2 times nothing, and then 6 times the 5, and 7 times nothing. So that's just 30 with 2 zeros, because it's 10 to the power 2. And then you add it all up, and you get 3484. You get it right? Let's try the next one. 723 by 249. So try this in your head first, or on paper, and then we'll pause for a moment, and then we'll continue. Okay, here we go. We have, let's start. 7, start with the innermost group, 3 times 9, of course, and then blank times 4, blank times 2. So it's really just the 3 times 9. That's 27, our first row. Then you move the arches again. We now have 2 times 9, 3 times 4, and blank times 2. 2 times 9 is 18, 3 times 4 is 12, 18 and 12, 30. That gives us, with the times 10 to the 1, 300. Next group, this is the more complicated one because it includes all 3 and all 3 products. So you got 7 times 9, 63, plus 2 times 4 is 8, plus 3 times 2 is 6. Total 77 with 2 zeros. Now you move the arch again. Your blank times 9 obviously doesn't do anything. 7 times 4 and 2 times 2. 7 times 4 is 28 plus, 2 times 2 is 4. So 28 plus 4 is 32. 3 obviously multiplies nothing because it's arches to a gap, to a blank. So that's the 3200, or 1000, I should say. And then finally, we have the biggest arch, comes out like this. Blank to the 9, blank to the 4, 7 to the 2, and then 2 to the blank, 3 to the blank. So 7 times 2 is 14, with the most zeros, 10 to the 4. Add it all up, 180,027. Hopefully you got it right. Now, what does this all have to do with trains? We did all those arches here to try to figure out 723 times 249. And I was thinking it kind of is complicated and that doesn't really help me see what's going on. I'm really not a fan of the arch method. And I thought there's got to be an easier way. So one option is this Braun train visualization. So what does this mean? Essentially, imagine 2 trains speeding past each other. Okay, you got this bullet train speeding one way, another bullet train speeding the other way, with numbers written on the sides. So here we have 723 times 249. Same exact puzzle we had before. What you want to do first is reverse the digits of one of the multiplicand, one of the numbers that you're multiplying. So we leave 723 on one train because we always have the 10 to the 0 digit near the front of the train. As you get further along on the train, further back, you increase the power of 10. Okay? So there, 10 to the 0, 10 to the 1 to the 2. This is obviously in the wrong direction because this is a 10 to the 2 number at the front of the train, right? That's a 200. So let's flip the numbers around. 249 is actually, this is the power, right? 10 to the 0 digit, 10 to the 1 digit is the 4, and 10 to the 2 digit is the 2, right? That's 249, read this way. And the same is on this train. The single digits is there, the power of 10 digits is there, 20, and the hundreds, or 2 to the 10, 10 to the 2 is a 7. Okay? Trains are speeding past each other, and watch what happens. Here they go. They're going. They're going to cross each other soon. The first two numbers are going to meet, and boom. First two numbers meet. 3 times 9 is 27. That's a power of 0 because you got a 10 to the 0 number multiplied by a 10 to the 0 number. So there's our first number match. Okay? We write it down. Keep racing the trains. Boom. All of a sudden, these numbers match up. These all happen to be 10 to the 1 powers. Why? Because up here, you have a 10 to the 1 power number multiplied by a 10 to the 0. And then you have the exact reverse on the opposite side. You have a 10 to the 1 number there times a 10 to the 0 number here. So if you multiply these out, you get 3 times 4, 2 times 9. They both go together in the 10 to the 1 power group. So 12 plus 18 is 30. We're going to sort them there for now. Okay? Keep racing the trains, and boom, they line up. All of these are exactly the same power of 10. Because remember, as we changed our power of 10 this way on one train, the exact opposite happened on this train with power of 10 digits. So when you multiply across, they're in the same, the powers of 10 add up to the same, right? So 7 times 9, 2 times 4, and 3 times 2. And you shift that. We're going to take all these guys and throw them into here, I guess. Oh, I put them the other way. Okay, I moved them here. And those are the 10 to the power 2 numbers. Keep racing the train. Oh, now these guys line up. See, notice how the ones that don't line up, we ignore. We ignore the 9, we ignore the 3 here, right? We don't need them. 7 times 4 is 10 to the power of 10 to the 3. 2 times 2 would be times 10 to the 3, because this is a 10 to the 2 power number, and this is a 10 to the 1 power number. And this is a 10 to the 2 power number, right? Because it's 249. And this is a 10 to the 1 power. Again, the powers always add up to the same. And now the race continues, and the trains keep separating from each other. The last two numbers finally meet up, 7 times 2. And those are 10 to the 4 powers when you add them up. When you multiply, because this is a 10 to the 2, and this is a 10 to the 2. So multiplying two 10 to the 2 numbers gives us a power of 10 to the 4. And that's the end of the multiplication. So the trains pass. Let's collect all our terms together. Okay, so all the 10 to the 0 number here just adds up to 27, right? Because it's 3 times 9. Our two 10 to the 1 numbers multiply out to give us 12 and 18, which will give us 30. On this side, the addition of all these, are their 10 to the 2 power numbers. This is our 10 to the 3, and here's our 10 to the 4. So that's the addition there. We'll just put them on a line and add the appropriate number of zeros, right? Because this has 1 0 after it. This would have 2 zeros. This would have 3 zeros. And this would have 4 zeros after it. Okay? So let's throw them in there with the appropriate number of zeros. And that's our answer. Okay? That's it. Now you can do this train method, I call it the speed train, the Braun speed train method, pretty much any number of digits. And it's easy to keep track of what you're multiplying because it's really just when they line up. If they don't line up, you ignore them. If they line up, you multiply and add all of the simple multiplications. And later, when you add them up to get the final result, you'll see it's quite easy. So past the trains, here we go. We're going to try this example. Now, I chose a pretty crazy size number here just for fun. 4,850,113 times 79,186. But don't forget to reverse the digits, okay, on the second train. So here we have 79,186 written backwards, okay? So let's start. Our first digit to line up, 6 times 3 is 18. That's our 10 to the power 0 group. Next digits that line up, 2 of them, because now 2 are lined up. 6 times 1 is 6. 3 times 8 is 24. We have our 10 to the 1 group done. Now 3 numbers line up. 6 times 1 is 6. 8 times 1 is 8. 3 times 1 is 3. We put that in here. That's our 10 to the 2 group. Now 4 numbers line up. We've got 6 times 0, which is 0. 8 times 1 is 8. 1 times 1 is 1. 3 times 9 is 27. That's in 10 to the power 3 group. Now 5 numbers line up. We put them in here. 5 times 6 is 30. 0 times 8, 0. 1 times 1, 1. 9 times 1 is 9. 3 times 7 is 21. Times 10 to the 4. That's our 10 to the 4 group. Now 5 digits line up. Because remember, we only have 5 digits on bottom train. So that's the most that are ever going to line up. So, and we're ignoring the ends here. 8 times 6 is 48. 5 times 8 is 40. 0 times 1, 0. 1 times 9, 9. 1 times 7, 7. And that's our 10 to the 5 group. Here, another movement of the train lines up the next group of numbers. 4 times 6, 24. 8 times 8, 64. 5 times 1, 5. 0 times 9, 0. 1 times 7, 7. And we add that to our 10 to the 6. Now the train is starting to not overlap every number anymore. You'll notice the 6 is now left the group. And we still have a few trailing here. These 113s have also left. So we do our next group here. 4 times 1 is 4. 8 times 9 is 72. 5 times 7 is 35. Okay. Another one here. We've got 4 times 9, 36. 8 times 7 is 56. And then last but not least, 4 times 7 is 28. Notice we're up in the 10 to the 10 group already. 10 to the 10, right? Because we've overlapped all of these times. And now the trains have departed. And we have this huge mess to add up. But even though it looks like a mess, it's not that difficult. Let's have a quick look at our addition. Okay, we have 18, right? 6 plus 24 is 30. 6 and 8 and 3 is 17. 8 plus 1, 9, plus 27, 36. 30 plus 1 plus 9 is 40. Plus 21, 61. And so on. These two middle ones are, getting a little bit difficult to do. Some of the bigger numbers here. But if you continue to add them up, you get this series of numbers, which you then convert to the proper values with the zeros by multiplying out by 10 to the 0, 10 times to the 1, you add 1 0 to the 30, you add 2 zeros to 17, and so on. The interesting thing is, though, it's actually not that difficult to add this because you'll notice there's an 8 and then there's just zeros all underneath it, right? There's a 1 and there's mostly zeros underneath it. 3 and 7, and then it's all zeros, right? 1 and 6, at most you have 2 numbers and then it's all zeros. See, that's 7 and then all zeros. 3, 1 and all zeros. 6 plus 4, so you carry the 1 here, but otherwise it's all zeros, and then 1 with all zeros, so you get 1 here. 1 and 5 is 6, right? 1, 8, 1, 10, so you carry the 1 up here. 1 plus 1, 2 plus 2, 4, so you get the 4 there. And then the last little bit here is 1, 9, 10 with an 8 is 18, so 1 goes there, and that becomes 3. Okay, but most of the additions here are going to be pretty much with mostly zeros underneath because of the multiplication, right? You're just padding it with a ton of zeros. So they're not going to overlap that much, so it makes the addition really easily. So, I think this method is quicker, potentially, and maybe easier to do in your head than, multiplying this out the old way. It's pretty neat. And you can do this just by writing two numbers on a piece of paper and sliding them across each other like you would these trains, right? And each time you do it, just write the numbers out, slide them one by one, and put down the answer, add them up, and get the answer. So anyway, I just wanted to show you this interesting insight into how perhaps Trachtenberg's multiplication method works, and using the train analogy to help calculate things. Hope you enjoyed this video, and if you find it useful, please leave me a comment, and thanks for watching. Bye for now.